This will be for the con assignment, probability with general multiplication rule. Okay, so the general multiplication rule. When we calculate probabilities involving one event and another event occurring, we multiply their probabilities. In some cases, the first event happening impacts the probability of the second event. We call these dependent events. In other cases, the first event happening does not impact the probability of the second. We call these independent events. Okay, really, the formula is basically the same in both cases. So I'm pretty sure in all of these problems we'll be multiplying the probabilities. All right. So Malik is a teacher who plays a review game with his class. The game involves writing each student's name on an identical slip of paper and selecting students at random. Okay, here's the makeup of his class. So they have the number of 10th, 11th, and 12th graders. Suppose that Malik picks a name, replaces it, and picks a name again. What is the probability that both students selected are 12th graders? Okay. So we want to find how many we're selecting from. Okay. So we need to calculate the total. Okay. And that's just going to be 6 plus 14 plus 5. Okay, so that's 25, right? And I'm just gonna put that right here. 25. Okay. So he picks a name, replaces it, and picks again. So we have a fraction for the first pick, and we're gonna multiply that by the fraction for the second pick. Okay. So the first pick, he's selecting from 25 students, and he wants to select a 12th grader, so he's selecting 5 out of 25. Okay, and now it says that he replaces it. Okay, so the second pick is going to be, the probability is going to be exactly the same. It's going to be 5 out of 25 again. Okay, so we can reduce these fractions. Okay, 5 over 25, divide top and bottom by 5. It's the same as 1/5, and same with the other fraction as well, 1/5. Okay, so multiplying numerators, 1 times 1 is just 1. Denominators, 5 times 5 is just 25. Okay. I'm not sure if they'll accept a fraction because it says so let's see if they accept 1 over 25. It says round to 2 decimal places. 1/25. Okay, great. They might even accept the fraction if you don't reduce it. I'm not sure. Okay. Hamid is playing a trivia game with multiple choice questions. Each question has 2 correct answers among 5 choices. Hamid has no idea what the answers to a certain question are, so he needs to choose 2 different answers at random. What is the probability that Hamid guesses both answers correctly? Okay, so we have 2 guesses here. So we're going to have the first guess fraction and then the second guess fraction. Okay, so he wants to answer both correctly. All right, so the first guess, there's 2 correct answers out of 5 choices, so it's going to be 2 out of 5. Okay, so that is the fraction for the first guess correct. Now, if he gets the first one correct, there's only going to be 1 correct answer left. And there's only going to be 4 choices left, right? So if he guesses the first one correct, the number of correct answers reduces to 1, and the number of choices reduces to 4. So the second guess is going to be a 1 out of 4 chance that he gets the second one correct. Okay, so we can cancel top and bottom. 2 divided by 4. 2 divided by 2 is just 1. 4 divided by 2 is 2. 1 times 1 is 1. And 5 times 2 is 10. So that goes in the box, 1/10. All right. There are 50 workers on site at a large construction project. 6 of them are left-handed and the rest are not. Suppose that the project manager randomly selects 2 workers without replacement. What is the probability that neither of the workers are left-handed? Okay. So we're selecting out of 50, right? And 6 of them are left-handed. So that means how many are right-handed? Well, that's just going to be 50 minus 6. That is 44. Okay? So that's how many are right-handed. And we want, after two selections, we want neither of them to be left-handed. So the first selection and the second selection. So the first selection, neither of them are right-handed. It's going to be 44 out of 50. Okay? And then when we select the first one that's right-handed, the number for the next choice, the number of right-handed reduces to 43. And the total reduces to 49. So for the second choice, it's going to be 43 out of 49. Okay? So I'll do this one on the calculator. Okay, so multiplying across the numerators, 44 times 43 is 1,892. 50 times 49 is 2,450. All right, let me just see if Con will take that answer. I know this fraction is not reduced because they're both even numbers. Let me see, 1892/2450. Big fraction there. Okay, good. It takes it. It takes it anyway. All right, so it takes the answer. If we were to do the decimal, if I did 1892 divided by 2450, I get 0.7722, and it keeps going. That would be 0.7722, all right? But they said 2 decimal places. So you look at the third decimal. If it's less than 5, you round it down. So it would just be 0.77 if you wanted the decimal. Okay, contestants on a game show spin a wheel with 24 equally sized segments. Most of the segments show different prize amount, but 2 of them are labeled bankrupt. Okay, right there and right there. Suppose that a contestant is going to spin the wheel twice in a row, and the outcome of one spin doesn't affect the outcome of future spins. What is the probability that neither of the spins land on bankrupt? All right. So if 2 of them are labeled bankrupt, how many are not bankrupt? Okay, well, we have 24 in total, and 2 of them are labeled bankrupt. So if we just do 24 minus 2, we have 22 of them that are not bankrupt, 22 spaces. Okay, and they said we're going to spin the wheel twice, Okay, the outcomes are independent, and what is the probability that neither land on bankrupt? All right. So the first fraction times the second fraction. The first fraction is going to be the first spin. And the second fraction is going to be the second spin. Okay, so the probabilities are the same. The first one, and in both of these, we want it to get not bankrupt. Not bankrupt. Okay, so the first spin to get not bankrupt, it's going to be 22 out of 24. And the second spin is going to be exactly the same. Okay, if we reduce these fractions, they're both even numbers, divide top and bottom by 2. We have 11 over 12 times 11 over 12. Okay, multiplying numerators. 11 times 11 is 121. And denominators, 12 times 12 is 144. So that's it. You can convert it to decimal if you want, but you have to round to 2 decimal places. So I think it's easier like this. 121 over 44. So in the box, 121/144.